Right, we're going to be looking at Newton's second law of motion. Personally, this is the one that I feel that a lot of students struggle with in terms of coping to understand and in terms of the calculations that follow with it. Right, so first thing we're going to look at is the definition, which is when a net force, which is F net, is applied to an object of mass, which is m, the object accelerates in the direction of the net force. So that you have to study no matter what. But the second part of the definition is pretty easy to understand as long as you can adjust the form, use the formula to assist you. The acceleration A is directly proportional to the net force and inversely proportional to the mass. So here is my formula. F net is equal to ma. The acceleration A is directly proportional to the net force. So if this value goes up, if this value for A increases, so does F net, as long as m remains constant. So, and also A is inversely proportional to my mass, right? So that means if A goes up and this remains constant, then B must go down. All right. So this is using this formula to assist us with this over here. Right, so let's look at a question, because I'm going to dive straight into a question to help us in terms of understanding over here. Right, let's look at this here. A 200-gram chalkboard duster slides to the right across a table until it comes to rest. The coefficient of friction is 0.38. 0.38. Determine the acceleration of the duster. So I need to determine the acceleration, and luckily I've got this formula over here because this has a value for acceleration. All right, so first thing, I've drawn myself a free body diagram, and I've also indicated to the marker which direction is positive, which is up as well as to my right. Then I'm going to look at the direction in my y, which is up over here. So I know that mass times acceleration for y is equal to 0. Why? Because it is at rest. Therefore, F net is also equal to 0. I also have my value for Fn. Fn is then going to equal to mg because there is no movement up and down. When there's no movement up and down, I know that Fn is going to equal to mg over there. Now we're looking at my x direction over here. Once again, ma is equal to F net, which is the same as that, but I also know that negative coefficient Fn is also going to give me all of that over there, because we're looking at in the x direction. So what does that mean over there? I'm going to take this value away, then you can see ma is equal to negative coefficient mg, because that's what Fn is. Substitute. Sorry. Substitute, you can see I've divided by my m's over there. Therefore, a is equal to negative that. Put that inside. I substitute. Here is my 0.38. There is my value for g, which is a constant 9.8. And now I have a value for acceleration, which is negative 3.7 meters per second. And that is my acceleration. Notice that it is a negative, and I have shown you which direction is going to be my positive, which is this x over here. Therefore, I don't write negative 3.7 meters per second, but I say 3.7 meters per second to the left. I don't have to put the negative sign because I know which way it is decelerating over there. Right, let's look at this other question here. Right. Nazli's father buys a bar fridge with a mass of 30 kilograms. He unloads the box containing the bar fridge in his driveway and starts to push it towards the house. At first, he has to push with a force of 135 newtons to get the box to start moving. So he first has to push it at that to obviously overcome static friction, because he hasn't moved it yet. Once it starts to move, we know he has overcome static friction. Once it is moving, he has exerted a force of 120 newtons to keep it moving. So now that he has overcome static friction, we are now looking at kinetic friction, because there's 120 newtons to keep it moving with a constant speed. And what do we know about constant speed again? We know that when there's a constant speed, my F net is equal to 0, because acceleration for constant speed is 0. So therefore mass times acceleration 0, F net is 0. 1. Calculate the maximum coefficient of static friction. And 2. Coefficient of kinetic friction. So we need to know what is the maximum coefficient of static friction. So how much do we need for this one over here, and this one for my kinetic friction. So once again, you can see I've put in my free body diagram just to show you in all the directions everything is moving. Right, here's my vertical. You can see Fn is again equal to mg. We know that it's not moving up and down, that's why I've got my 0 over there. But once again, Fg is also known as my mass times gravity. And I do have a value for mass, which is my 30. My gravity, you do know, is a constant. So here you go. Fp, my force pushed, is equal to my friction, which is equal to coefficient Fn. Right? Then I'm going to have over there, substitute, adjust my formula, so I'm looking for this. So I'm going to divide by Fn on both sides, this side and this side. So you see coefficient is equal to Fp over Fn. My force push, my pushing force is 135 newtons. At first he has to push at a force of 135. So there's my force of push over my Fn, which is the same as mg. Fn mg over there. So 30 times 9.8, and I have a value of 0.46. So this 0.46 is my static friction, right? And I've used Newton's second law for this one over here. And the same thing goes over here, the coefficient of kinetic friction. Now I know when I have kinetic friction, he's actually pushing it at 120 newtons now. So I do the same thing. You can see it's the same as that one over there, but you can see for my FP it should be different because he's using a less amount of force, which is not 135 but should be 120 over there. Then you can see my value is 141 for not 141, 0.41 for my kinetic friction. But notice my kinetic friction is lower than my static friction, because generally, like I've said, it is difficult to start to push something, to try and push it. Once it is in motion, then my kinetic friction is now in use, and it is a lot less, you can see, compared to my static friction. Right, I'm sure you already saw. I've got two other questions for you. For Newton's second law, the only thing now we're going to be looking at it on an incline. A 1,200 kilogram car accelerates at 1.4 meters per second up a hill that is inclined at 7 degrees to the horizontal. The coefficient of friction should be calculate the coefficient of friction over here. So first thing, I have drawn my car over here. Now notice this normal force is incorrect. Why is this normal force incorrect? Because you can see this is not perpendicular. However, this is perpendicular over here. So don't draw this Fn over there. I've drawn a free body diagram, and I've also drawn I've drawn a force diagram, and I've also drawn a free body diagram over here, as well as my Fg over here, 7 degrees. So now I've got my Fgx as well as my Fgy. So I'm going to first calculate. Now I'm doing the same things that I have done with my last calculation for my Newton's second law. Right, the only difference over here is I've just put in my cos 7. Why am I looking at my cos 7? Because you're using the same formulas you did for when you were looking at things on an incline, which is this worksheet over here. Can you see? Yeah. So looking at this one over here. So I am first looking at perpendicular. Perpendicular is this one over here. right? So you can see perpendicular. There is perpendicular FGY. So there you go. FGY is equal to FG cos 5. FG cos 7 now, right? So therefore my value for Fn now is FG cos 7. Now I've got my perpendicular. That is why we do this one over here. Okay. Now I'm going to calculate my parallel, which is going to go in this way. So now we know it's not going to be FG cos 7, it should be FG sine 7 now. All right. Why? You can see over here, FG sine, this one would be a 7 because we're looking at my parallel, which is this one here. Okay. Just see everything is centered. Yeah. Okay. Then I'm going to use my formula over here. Therefore, friction is equal to, you can see I've taken it over the equal sign, mass A, which is this one over here, plus all of this over here. So I've taken it over and it's changed from a negative to a positive over here. Now, what is my value for friction? Friction, you know, is coefficient Fn. But since we have coefficient Fn, we know that it can be friction is equal to coefficient Fg cos 7. Where did that come from? This one over here. I've just substituted my Fn. But I don't have the value for Fg either. So I have to substitute Fg with Mg. So friction is equal to coefficient Mg cos 7. Right? And I do have a value for mass, which is 1,200 kilograms. Okay? So there you go. Now I'm going to substitute that in. All of this where my friction is. I'm substituting this all where my friction is, and I've still got all of this. I'm trying to get coefficients alone, so I'm going to divide by my cos 7. Right? Mg cos 7. I do it on both sides over here. Now you can see this has cancelled out with that, and this mass are all the same. All I've done is taken out I factorized it. I've taken out a common factor of m, and I've divided it all by m. So now I'm just left with a g sine 7 and g cos 7 over here. Therefore, my coefficient is going to equal to 0.23. What I want you to do is also, please, while you're looking at this, maybe pause the video, try this with your calculator and see if you get the same value as me, so that you know exactly what to do in a test as well. So this is looking at it on an incline, solving for this over here. So remember, whenever we are trying to solve for something, let's say coefficient, you need to find a formula that has a value for coefficient. So I have friction. I know that friction will have my value for coefficient over here. If I'm looking for acceleration, I know I need to use my acceleration over here. If I'm looking for mass, I need to find something with mass. You need to adjust the formula to what you are looking for. Right, here is another question. A block, let's go. A block on an inclined plane experiences a force due to gravity. Fg of 137 newtons straight down. If the slope is inclined at 37 degrees to the horizontal, what is the component of force due to gravity perpendicular and parallel to the slope? Once again, here is my perpendicular, which is this one over here, FGY, can you see? And this is my parallel, FGX. All right. If you want to go back into that video, just so that you can remember, revise that as well. So let's look at my parallel first. Right, looking at my parallel, this over here is the formula that you have started off with. So I'm looking at parallel first, which is this one here, parallel to my surface. Right, I'm solving for FGX. I'm solving for this value over here. So you can see I've just multiplied by my FG on both sides. There it goes. So now I've got my FGX. I've just rearranged it again just so it looks better. FGX is equal to FG sine theta. Do I have a value for FG? Yes, I do. Fg of 137. So I put my value for 137. If I didn't have this, you know that we could substitute Fg with mass times gravity. And sine 37, yes, because I've got 37 over there. And there you go, 82,45 newtons. Right? And we know this is parallel, so it is negative in the x direction. So it's going in the opposite direction to my x. Perpendicular, same thing over here. I've got to my cos theta, but what do I do? I'm trying to look for this over here, so multiply by Fg on both sides. So I've got Fgy is equal to Fg cos theta. Fg is a value of 137, and my cos 37 comes from here as well. Multiply it, and you see I've got 109,41 newtons going down. Right, and there you go. Got it from this over here, which I've adjusted into this formula here. Right, and that is Newton's second law, just with our angles and generally how to calculate them. Right, thank you very much.